quick jump over to our syllabus and quick jump over to here. Is anyone okay? I'm there. And that's there, just in case anyone pops in. And that's recording. So we'll start with 2 minutes left, or 2 minutes before, 3 minutes before. So we're getting towards the end. I think everyone should, more or less everyone, there was a couple of glitches in the last minute getting projects in and things, but there should be grades up and all that. There was last week, I think, right? Everyone get their grades. So we're homing in on things. Still lots of room for lots of points to be scored. I think everybody is still in a range that they can, make of it what you will. Some people may be out of the official 100-point range. Basically, I'm cutting some slack on the 60-40 split. What was originally the design of the gamified scoring system was that you could get 40 points, 10 points for each. There are 10 project points or 10 design game points for each project, and then 60 plus feature points. And the idea was that you couldn't really, you couldn't get to 100 without getting kind of both. So you couldn't be like, okay, I skip all but one project and just really get 90 feature points on that one project. Don't want people to do that. So I loosened up on that a little bit in so much as you can basically gain back or gain some project points, up to half the project points. So you can overcome, if you got a 5 on a project, a 5 out of 10, you can get 5, you can use 5 of your feature points to get beyond that, right? So if you got 70 feature points total, and you got 2 10s on 2 of the projects and 2 5s on the other projects, that would get you to 100, so you could still kind of get there. And the idea behind it was that if you skip a project, you can't get more than 5 feature points for that project. All right, so if you skip a project entirely, the best you can do is like a 95. If you skip 2 projects, the best you can do is 90. Skip 3 projects, you can still somehow get an 85. Skip 4 projects, I don't know what's going on. That's real tough. That's a real tough one to convince. No projects at all, but you just like did tons and tons of kind of proof of concept things. You can get to, I guess you could get to an 80, maybe? No, you can't get to, maybe. I don't know, that'd be interesting. So I don't think anyone's in that boat. And there have been, I'm counting the things like the reactions from other, your playtesters, and there's going to be a playtest and a design document piece for the final project. So that's bonus feature points above and beyond, right? So those are good points to get. I'm going to add a few feature points that may not have been in the list, so we'll add some new things like using particle systems or some of the more interesting things with regards to the universal render pipeline and lighting, and if you want to get crazy with materials or shaders or things like that, those are good for points as well. Or if you want to say, hey, I tried this cool thing that wasn't on the feature point list, can I get feature points for that? Usually if it's something cool, I'll be up for that. So I think everybody's in pretty good shape. Everyone who has been certainly turning in projects, at least if you've turned in 2 out of 3 so far, I think you're in the throwing distance to get a pretty good grade. And that should be that. So we are at, where are we? August 2nd here. We've already talked about inheritance and design patterns, though. You know, things like the basically the state machine design pattern there, and the subscriber, publisher subscriber, and the singleton, and so on. We've also talked about inheritance. We did that lecture. So we're actually pretty good on a lot of features at this point. But one of the things that I wanted to look at sooner than later, a couple of things, I'm kind of moving this, what was next Monday's piece, particle systems and lighting, and kind of getting a little bit more into how to enable lighting and what that sort of opens up with regards to Unity specifically. But it also reflects on most game engines when we talk about the rendering pipeline, or the thing that's happening kind of behind the scenes that's really doing kind of the whether it's OpenGL or Vulkan or Metal or whatever underlying graphics hardware system is kind of under your game engine, how it is really rendering stuff to the screen, and how you can leverage some of that capability in your games to do, you know, you're not just drawing the same pixels in the exact same way. Look up a pixel, put it up on the screen, maybe scale it or something like that, but to do something interesting, kind of opens up a whole bunch of things. So I wanted to talk about that today a little bit. We will likely, on Thursday of this week, because of the way my other classes are running with regards to having a semi-final exam, we'll probably not meet in person, or we'll just say at this point, we won't meet in person this coming Thursday. All right, so I'll give you a chance. If you haven't already seen, I posted a bunch of things about the universal render pipeline and lighting and shading, some of those things in the Discord channel already, so you can kind of continue from that if you haven't, or jump into those. And I'll be around. I'll be, you know, certainly online, so it'll be more of an online class than an in-person class on Thursday. So it's this Thursday, what, August blah, 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 the 5th, right? So, all right. So we're fully into sort of platform territory now. Platform game, we're still 2D. There's actually kind of a little bit of room for some 3D, and potentially this sort of starts to open up things. Something that happens quite often in games like this, these side scrollers, and I'm not going to talk too much about it today. We'll leave it. I think it's a good one to actually make I think I have a short video for it somewhere, or a couple of short videos. The idea of using parallax scrolling. All right, so what parallax scrolling is, it gives this sense of depth. Games like Limbo or Inside, or lots of different games use them. Kind of the 2.5D games always tend to use them to particular effect, where they really kind of make you feel like, you know, things have a sense of depth to them. And the basic idea is that you have sort of multiple planes that move in front of or in back of each other at different rates, and it gives us this real feeling of kind of things being further away, because objects that are further away appear to move slower. It's kind of like when you see a jet in the air, you know, you think it's moving really, really slow, whereas it's back moving hundreds of miles an hour. So by playing games with things that may be, you know, Disney does this, you know, Disney was a pioneer of this sort of thing when they were doing cell animation, and everything would be flat on a single plane, and you just kind of move the background at a different rate. We can actually use this in 3D, though. So depending on how you do it, you can use this as sort of the gateway to starting to think about the world as being in 3D. And I'll just hint that a little bit. If you click that 2D little clip button there, you may have been wondering about that this whole time. And kind of, I'm doing the middle mouse button here and just kind of scrolling around and looking around in the world here in 3 dimensions. So all this time, a full-fledged 3D engine has been, you know, hiding behind all of this 2D stuff that we've been doing. So it is there. And you can even, of course, specify a Z position for all sorts of things. So we don't have to just put things flat and play that game. We can even put things further into the scenes, or closer to the camera, or closer to the viewer, that sort of thing. So we'll think about that a little bit. But we'll stay in 2D, stay in familiar 2D territory for now. All right. So I'm going to go ahead, and this is one of these things where we sort of have to do it from scratch to appreciate it. After you do it a bunch of times, it gets a little bit easier. I've done it, I don't know, half a dozen times, and I still get confused once in a while. And it's a matter of telling Unity that you want to use a different version of the rendering pipelines that they have, right? So by default, Unity has a standard rendering pipeline that it builds in. And it's just based around a typical, I want to say, typical programmable pipeline, very similar, OpenGL, kind of traditional approach to programming and its materials and so on. But in the more recent releases, we have the standard rendering pipeline, which is what we wind up using by default. Then we have two new rendering pipelines, one called the Universal Rendering Pipeline, which is called Universal because it's supposed to be for most platforms, for things like mobile devices, and I believe it works in WebGL in most circumstances. Yes, it does, because I did the Knuckles game in Universal Render Pipeline, and it works in the WebGL. So it does a lot of stuff, and it looks really good, has lots of features, and it's pretty modern and so on. But it's not the perfect pipeline. It doesn't have kind of all the bells and whistles, we'll just call it, in terms of all the latest hardware and so on. And there's also a high definition, the HDRP, the high definition render pipeline, which takes off all the training wheels and says, okay, now we're going to take advantage of every hardware bell and whistle that you possibly have. Nothing is off limits with regards to all the features of the PC and latest generation game hardware. So it's less mobile friendly, less web friendly, and so on. But it really tends to be the most dynamic, accurate, really cool looking graphics, on par with what we see in the Unreal Engine. So Unreal typically focuses their efforts on PC and next generation platform kind of stuff. We see a lot in PS4, PS5, Xbox, Nintendo Switch, all the latest stuff. Unreal isn't typically known as being the mobile gaming platform. It tends to need the hardware. So they just, by default, build in a really, really cool rendering pipeline, make it look really great. Unity has you kind of make that decision, and to some degree, you have to sort of still make more decisions of your own as you go on. But that's why out of the box, sometimes you get this feeling that, like, oh, Unity isn't look quite as good as Unreal, because it is using a lighter weight. It used to be called the lightweight render pipeline. Now there's the standard pipeline and the universal pipeline. And they're always improving it still. So it's a work in progress. So what I'm going to do now is I'm going to create a game. I'm just going to say, now you'll notice there are some buttons here for high definition render pipeline and universal render pipeline. I'm going to recommend you not use those if you want to do it, for the first time. You probably should do this in something other than your project that you've been working on, until you do it at least once, feel comfortable with it, make a backup copy of everything, then do it again. But I recommend you not choose one of these two, the HDRP or Universal Render Pipeline, and instead go through the process of creating a standard render pipeline project and then change over to it. Right? So you don't get all the extra assets and other junk that they kind of throw in. Unfortunately, they throw in like an extra set and like a sawhorse and some things, a scene and extra assets. It's a pain in the butt to have. So we're just going to say a 2D project because we're familiar with that. And we're going to call this, it could be anything. You're not going to hand this in, but 2D URP, we'll call it. And we'll just create that. And it'll look like any other game that we've had so far, or any other project. Nothing all that exciting about it. Give it a second. Take time to breathe. Da-da-da. Boy, it's taking its time. It's always slower when it's showtime. And this is just a normal project. We haven't even imported anything to it yet. Okay. There we go. Bouncing right along. Okay, so I have a sample scene, nothing in it. And just for the heck of it, I'm going to load in some assets. This is going to be something I've done, and even the universal render pipeline, you install it as a package. So you actually used to get it through the asset store, but it's all this part of this package manager at this point. So I'm going to go to the package manager, and I'm going to add in actually a bit of just a game kit so that we have something to play around with here. So I'm going to say my assets, and I had, let's see. I have a 2D jungle side-scrolling asset pack here. So I'm going to grab that one, and I should have grabbed one that I already had. That would have been smart. It'll take me longer to find one that's already installed in this machine than it will be to download it. This is what I get for now working on two different machines. So if you want to check out the 2D jungle side-scrolling platformer pack, by all means, do that. You can find that one. And this is a pretty old pack. You'll notice it's supporting Unity versions 5.5 and later. It's not even a 2018, 2019 kind of thing. It was released in 2017, so okay, hopefully it all works. That gives a good proof that we can update things to universal render pipeline without too much difficulty. So I'll say import, and it has all sorts of great stuff. It actually has an example scene. We have some night assets, sunset assets, day assets here. Great, fantastic. So I'm going to say import. And we'll import everything into the game, into the project. I need that background music. How's the weather doing out there? See dark clouds, or is that just an illusion from here? Cooled off really amazingly, that's for sure. All right. Mental note, never download something called Mega. It's all the background images. That always does it to you. All right. We're almost there. Unity's big summer sale is ending on August 9th. So if you're looking for add-on assets and spend all sorts of money on ridiculous plugins, if you like, on the Unity site. I know I did. I went on a binge. Okay, so we have that installed now. All right, so if we come in here, we'll go in our Brutal 2D and go to our example. Let's see what this looks like. Oh, they changed their, what do we got here? All right. So we have a little game, a little setup here. Nothing too exciting. And can we move around? I guess we can't move around. We don't have anything moving in the scene yet. So we'll maybe wind up just using a simple 2D sprite. It's going to be a circle. Right? So there's our little circle, and we'll bring it out and open here. So happy little circle. All right. So we have a happy circle. We have a scene. We could even really simply, we're going to add a super simple controller. A circle controller, we'll call it. Just why not? And we're going to go ahead and use the input get axis like we did. And we're just, this will enable WASD control and directional keys and joystick just like usual. All right, so I'm going to do it the real cheat way. I'm going to say vector2 direction and we're going to say direction.x equals input.getAxis horizontal, and our good old vertical for direction.y. And just to be good citizens, we're going to say void fixed update. And we're going to say, we're going to put a rigid body on it. So we're going to say get component, rigid body 2D, dot velocity equals direction. And let's see, I better make that a class variable, a class attribute, class property. And times speed. And we're going to make public float speed 3 equals. All right. Sort of convinced that'll work. And we're going to make sure it's got a rigid body on it. Rigid body 2D. And we're going to make gravity 0. So, if all goes well, hit play. And there's our, it looks like our sun. It's kind of, oh, it's in the background. Interesting. We'll use that to our advantage. So we have this, the sun in the sky. That's going to inspire us here. So we'll save. And definitely worth saving at this point, because now we're going to take the step saying, let's use the universal render pipeline, because we want to do things like add 2D lighting, right? 2D lighting and post-processing. We want our game to really stand out. Enough with the 2D flatlands now. We're going to really start to give it some oomph. So the next thing is I need to also install the universal render pipeline, and I do that also through the package manager. So I'll look for Unity registry. And the asset I'm looking for is, if we look at universal, you'll see universal RP, universal render pipeline. Now the good news here is I can just say install, because I've already downloaded it. It's going to install it. I wouldn't immediately see any differences, because it actually is installed but not active. It's not really installed and active as far as the rendering, the graphics go in the game. So we have to tell the engine now to go ahead and use that pipeline. All right, I saved the download time, but I didn't save this time. Let's move them quick at least. Oh, come on. Seems odd that they always like that last, what looks like 100% on their little bar is never 100%. It always goes like, gets there and then it sits there for at least as long as it seemed to fill in the first place. So it's loading all of its shaders, the styles, the controls, everything it needs to give us that. Now, an interesting thing is, because of the way that Unity engine allows for a scriptable pipeline, you could actually write your own render pipeline in Unity as well, which is not a trivial task. But you can also do things like extend the pipeline through things like writing post-processing shaders and stuff. And that's something that's fairly reasonable to do, especially if you do take advantage of like some of the shader graph type languages and things like that. We'll just use some of the built-in post-processing and lighting though. All right, so here we are. Nothing's changed other than it says that it's installed. All right. So next up, one thing to look at right now, you'll see in the circle or any of my assets that are already in the scene, they all have a material on them, right? So the sprite default material is typically what we're going to see on them. So even in trees here, sprite default material, right? So on. That's just the one, it looks up. It has transparency. It has, basic capabilities. Not all that much to look at here, right? We've got a sprite texture. You can tint it. You have some alpha blending. Where in the queue is it? When it talks to queue up all the different things to be drawn, but not much. Not much going on. So next we're going to do is, if you look and we go to project settings now, there is a scriptable render pipeline setting, right? And this is where we want our pipeline to be. We want to put in the necessary information to get our universal render pipeline asset in here. So we have to create some assets. So I like to just do this right in the root for now. Say, we right-click, create, and we're going to create a couple of things. Now, so once we are installed here, we should see where am I seeing it? Rendering. So under rendering, we'll see now universal render pipeline, which is something new. And we could say, just give us a pipeline asset, right? And it'll actually create two assets for us here. A universal render pipeline asset and a universal render pipeline asset renderer, right? So the renderer is the part that goes in here, right? Oh, no, I got it the other way around. The asset is the part that goes in there, right? Not the renderer, right? So now we're telling it we're using the universal render pipeline, right? And if we double click on that, or we see it in the inspector, we'll see a reference to this universal render pipeline asset renderer, this thing that it just created. Right. Now that would be the normal renderer if we were not in 2D. So this is where it gets a little bit special. Because we're in 2D and we want to use 2D lighting and so on, there's an extra step. So from here we have to create, you can go now create again, and under rendering universal render pipeline, you'll see that there's an extra 2D renderer. So normally when you say pipeline asset, it creates the pipeline asset and a forward renderer for you. That's this thing that we saw over here, right? but it's just the normal one. And what we want to do is we want the 2D version. So we're going to say 2D renderer. It says experimental, but we're going to go for it. And use a new 2D renderer. And now, if we find this again, we're going to swap in our new 2D renderer data for that other one. So this one we don't actually need anymore. If you wanted to get rid of it, we could do that. So we'll even do that. Delete. Yes. All right. That's the one we're using. All right. Still nothing's changed, though. We haven't seen anything change at all. So you'd have thought, well, maybe by now something would have changed, but it's not. So we have a few more steps. So now let's see. We look here, project settings. We told it to do that. And next up, we want to go to the edit render pipeline, universal render pipeline. And we can now say, upgrade the project materials to universal render pipeline materials. And you'll see there's also 2D renderer, upgrade scene to 2D renderer, upgrade project to 2D renderer. So choose one or the other. And you'll notice that everything disappeared. Well, it didn't really disappear, it just turned black, just vanished. And that's because now, if we look at things like circle, sprite lit default material is this keyword here, lit, and it's using the universal render pipeline shader. Okay. So now it's lit, which means, well, we need some lights. It's reacting to lights in the scene. So good idea to give it some lights. So if we right-click here and we say, well, let's create a light. And you'll notice now there's 2D. There's freeform lights, sprite lights, parametric lights, point lights, and global lights. So the first thing usually what you want to do is create a global light. And that just means that's all this bounced light in the scene, the sun in the sky or something. That's where that comes from. Right? We have some light in the scene. We're going to turn it down, though. We don't want it at an intensity of 1 because that's just going to light everything with that particular light. So let's set it to something just enough so we can kind of see what's going on. For the projector here, I'll turn it up. I'll make it 50, 0.5. Right. So now we have some light in the scene, which is good. All right. So we can see that now. You can change the color of the light. You could say, well, this should be the sun, maybe. So it should be this kind of yellowy. Ooh, it makes everything hardly green. Yeah. I'm bad at picking light colors, but we'll something there, I guess. Give a little bit of light to it, a little bit of color to the light. And now let's turn this circle really into the sun, right? So you can have other lights in the scene. You typically only have one global light to give the scene some light, but then you can add lots of other lights. So let's say we add a component to the circle there, and we don't want it to be a new script. We want to say here we'll go to rendering 2D, light 2D. All right. So I just added this parametric light here, and you notice it's got like a cool shape, but let's do something a little bit more simple and just make it a point light. Okay. So light is going to emanate from our little sphere there. So you notice it already has, it's casting a little bit of a light around there. And we can kind of increase the radius. Notice the outer radius. We have an outer radius and inner radius. All right, so if you want to really like a hot spot in the middle of it, do that. I guess it was the sun. I like that kind of hot spot in the middle there. And okay, we'll leave it at that. So now I'll go to my game view, and I'm going to move my sun around now. So you'll see now I get a nice lighting effect. It's shedding light on different parts of the scene. Right? Okay, so there's part one. So you might next want to say, well, all right, we've got lights. Once we have lights, we also want to have shadows. So we need some 2D shadows. How do we do that in this? So I'm going to go to, I'm just going to create an empty. And you could do this, you can put the shadows on other objects as well, but you can also just create an empty that has them on there. I'll put it at 0, 0, 0. And add component. And if I type in shadow, you see it's Shadowcaster 2D. There's a Shadowcaster and a composite Shadowcaster. For now, we're just going to grab the Shadowcaster 2D and go to our scene. And you'll see now it started off with this little box for us here. And it's a little shape that we can change if we say edit shape. So I'm going to put this around this little shrubbery thing here. Or maybe I'll go a step further and I'll say this whole platform. All right. So you can make it any sort of polygonal shape you like. And I'm going to bring this down into the scene a little bit. Well, let's see what it looks like. And immediately nothing happens. And that's because light and shadows and the way that they interact is not a trivial calculation. It's not, right as of now, even with all the latest technology and things, just assigning infinite numbers of lights and infinite shadows and so on can get expensive really quick. So a lot of the time, what you'll do is you'll say specifically which objects can cast shadows, which lights cast shadows, and so on, right? So you can kind of optimize things. And sometimes you even wind up optimizing those away because, hey, the shadows aren't really in real time. You can tell it to kind of bake those into your textures and things, but we won't worry about that just yet. Instead, we're just going to go to our lights here. And my light 2D experimental that's on the circle, I'm going to tell it to say, use a shadow intensity of, say, 0.7. All right. Now, that's not enough to do things. I get out of play mode here. So we'll go back, circle, shadow intensity to 0.7. And let's see, shadows. Okay, we don't have to worry about it. Cast shadows is on, and self shadows is off. This is like whether or not its shadows hit itself. So we won't worry about that one just yet. But let's get the basic. So now you'll see, no, not there yet. Oh wait, no, it is there. So you'll see here. The light is hitting it, and it is shadowing things over the other side here. All right, yeah, here's the thing, self-shadowing versus not. So now it's not self-shadowing, meaning if there's light shining on it, you can see it. But the light does not go through it. So let's see. Yeah, I'll scale that up. Make it so you can. So if you look over in this area right here, that is actually a shadow that's being cast by our light, right? And if we're down here, you'll see that up here, it'll be actually easier to see if I turn down the intensity of my global light here and move my light around, you'll see that even though the surface gets lit, things that are beyond won't get lit. So even though I'm allowed inside, it doesn't cast light outside until I get to that point. It's interesting, the combination of the fact that the circle itself is behind this layer. Right? I didn't really create that, so that the white light of the dot is kind of working out really well. Because I'm actually behind this mountain. The sun is behind the mountain. Maybe I want to go in and make a shadow map, another shadow map for this mountain over here. So I could go shadows, and I'll add another component and another shadow caster. Well, how do I use the composite then? I guess, all right. Let's see, edit shape. Let's create another object. Empty mountain shadow. And shadow caster. Edit shape. Something like that. And we'll say that in this case it self-shadows, meaning it won't get lit as the sun goes behind it. So that's the basics of lighting and shadows here. There's a few different types of lights you can have. Like you'll notice we had just our plain point light. What a point light is basically light emanates out in all directions from that point. You can also have a sprite light, which is based on a shape. I'm not going to do that. So you can have a shape that emits light according to the shape of the sprite, or a freeform sprite, a freeform light, which is really handy for doing things like creating kind of spotlight effects and things. I think, can I get rid of that one? No, put it there. So, for example, now I could kind of cast a little spotlight action. And let's see, fall off, create a fall off offset. Opacity of the volume, intensity of the shadows. Let's see, I'll make the volume a little less. And then if I wanted to, I could spin the object that's on and create a searchlight pattern or something. Kind of one fun way to do things. So that's the free form. And I think in the point light, can you adjust the angle as well? Let's see. There was one that was a little bit more. Oh wait, no, is that? Yeah. Okay. There are inner and outer angles to the spotlight as well. or the point light that lets you kind of create a more traditional spotlight. Kind of thing. So now if we rotate that, imagine we could do a little bit more convincing of a spotlight with the point light with inner and outer angle limitations on it. And what other kind of light do we have? We have sprite, freeform, and parametric. It's more just like a arbitrary number of sides. We set a radius. So it's basically a parametric shape. So if you wanted to do hexagons, pentagons, triangles, squares. Let's see. I don't know how fun and interesting cube lights are. Weird. Okay. Let's go back to just a point light on that one. I think that worked best. Kind of created a sun. And they don't have to be moving lights or anything like that. The nice thing is that if the light was here, we'll do this a different way. We'll say, all right, instead now, I'm going to add another object to the scene, another 2D sprite, and I'll make this a capsule. Well, let's see. Let's get into the scene mode again. 2D object, sprite, capsule, and make sure it's in the front. And this, I'm going to put the circle controller on. Why not? So our circle controller, and I'm going to take the circle controller or disable the circle controller from the other one, and I'm going to, on my capsule, well, I guess for starters, we'll just see that it will be lit as it, what did I do here? Oh, it also needs a rigid body. That does not have gravity. So you see it gets lit. So you can wander around in darkness until it sees a certain light. And if I wanted to, I could also do things like add a shadow caster to it. So as it moves around in the scene, it can block the light. Might need a little bit of tweaking there so it doesn't look quite as rectangular as that. All right? So you can have your characters carry torches, or your cars have headlights, or they have to walk around and you only see when there are torches in the area. So you can have moving lights, you can have not moving lights, you can have whatever you like. So that's the basics of lighting, shadows, and kickstarting the universal render pipeline into a project. Now, one other thing I want to show you is another kind of shading pipeline effect, which is post-processing. So a lot of the time you get your scene looking kind of cool, but then you're like, well, maybe, like if you're familiar with, everyone's watched The Matrix, right? Has everyone seen The Matrix? The Matrix has a very specific look to it, especially when you're in the matrix versus not in the matrix. There's different kinds of color tints. There's different kind of tones that get used. And all movies, almost all movies, all certainly big budget movies, have some sort of like color correction or color grading applied to them to kind of make it kind of look a certain way. If you watch a Coen Brothers movie, you watch Oh Brother, Where Art Thou or something, it has very warm tones and so on, and very kind of warm and dry Midwest, kind of straw almost kind of thing. Compare that to a sci-fi movie, which is stronger blues and greens and so on. And even within one movie, you may have shifting color grades depending on what character's on the scene or where they're supposed to be, or so on and so on and so on. So the idea behind post-processing is to allow you to do that sort of thing, create an overall kind of look to what the scene is doing, or kind of what the camera is doing or is perceiving. And that now with the universal render pipeline, it used to be that you would add a post-processing asset or a post-processing package. With the universal render pipeline, the other nice thing is that you get this kind of built-in post-processing stack that you can use. So to use it, if you right-click, you'll see there's something called volumes. And for now, we're just going to say global volume. And that's just going to create a global effect volume or a global post-processing volume. It doesn't look much like anything. It just says global. And you can create a profile. Right now it has no profile. So if, say you wanted to have a certain look that you use throughout your game. Some levels had this look. The underwater levels all had a certain look versus the desert levels, they all had a different look. The nighttime scenes have a different look. You could create a profile for each of those. So I'm just going to create a default one, and we'll call this daytime. Or I'm going to call it old-timey. All right. So our global volume is using the old-timey profile. So let's go to the game scene, the game view just for now. And I'm going to look at that. I'm going to add some overrides. So the overrides are the post-processing step. So I'll click on that. And for my old-timey one, the first thing I want to do is add a vignette. Right? What a vignette is you'll see in just a second, is kind of this darkening of the, let's see, scene. Is this darkening around the edges of what the camera sees, right? It used to be a real, old-timey film kind of thing, right? It just, the film doesn't expose evenly. So at the edges of the gate, it would kind of expose differently. So create this dark kind of effect, which is kind of really cool, cool old-timey kind of thing. Now you'll notice in my scene view, I'm getting a sort of a preview of what's going on in scene view, but the game doesn't have it in there. The game doesn't see our old-timey effect. And the reason for that is because you also have to go to the camera and tell the camera to use post-processing. Right? So we're going to make sure under rendering now, there are a bunch of things. We have things like rendering shadows and post-processing. I think these are not the 2D shadows. These are the real shadows, the normal 3D lighting shadows. But we do need to say to use post-processing. So now we have that wonderful, our old-timey vignette around the scene there. Right? Creates a much cooler thing. Now, let's think old-timey some more. What else would make it old-timey? There's another one in here called film grain. Right? So you simulate the analog process. The good old film is made up of this various chemical processes and particles on the film that gets the silver nitrate and so on. That gives film its kind of look, this grainy texture to it. So I'm going to create some film grain on there, and you'll notice it. I don't know how much you can see on the screen up there. I'm going to make it really overdone, and we'll say maximize on play. So yeah, the dynamic range of our projectors don't quite do it justice here. Let's increase the dynamic response of our eyes a little bit here. So now we have a real kind of old-timey, cartoonish kind of thing going on between the vignette and our kind of sizzling film grain in the background. You know, way cooler than, way more personality or feel or something than you know, just, let's see, let's turn that off. And if we cranked our whoops, well, we can overblow our lighting, I suppose. You know, our default lighting and so on. So entirely changing the look of the game by kind of playing around with, you know, what's going on. We got that, get that back down to there. And we'll go back and turn our effects back on. Right. A whole new bunch of stuff, a whole new way of doing things. And the list goes on in terms of the effects. So normally you add an override, and then you say, okay, what parameters do you want to change? And usually each one will have, I think, an intensity, normally an intensity parameter, which starts off being 0, so immediately it doesn't really do anything, and you can then change it. So let's see, what else in here? We wanted depth of field, not so much useful in a 2D game where the camera, you're modeling sort of the way the camera focus works with regards to the f-stop setting, how wide the iris is open on the camera. It's how much of the scene is actually in focus or not. We have the wonderful bloom effect, so that light sources can be overexposed, creating that kind of great bloom effect that so many games had, similar to, you know, the good old Tron effect, and you know, emissive light sources then kind of exceed the start to illuminate other areas in ways that they sort of unnaturally do, a bit of overexposure. So we could turn off our bloom here if we don't want it. And you have things like you can color correct. So if you wanted to go ahead and turn it into, I'm going to do a terrible job if I try to actually like shift it. You know, I want to make it a little bit more nighttime-y, a little bit, you know, shift in the hue, saturate it a little bit more. Or I could desaturate it, turn it black and white. Right? So suddenly you have a scary kind of game going on there. So not only is it old-timey, but it's now a little scarier. Play with the contrast. And then lower contrast makes it look a little more old-timey. Higher contrast makes it a little scarier. So on, overexposing it. And so on and so on and so on. All right? You can do things like have volumes that only affect things that are within their volume. This is a global volume here. You notice there's also things like when I saw volumes, they were box volumes, sphere volumes, convex mesh volumes, and so on. So you can affect certain things, like as your camera moves into a certain volume, that's when the post-processing is applied. So you can even have it change not, well, on a, you know, as the camera moves throughout the scene, or objects move throughout, and so on. So that's a really cool effect, a way to make your game very much give it more personality. So using post-processing, that's a feature separate from using the universal render pipeline. Lights are yet another feature. Shadow casters, yet another feature. Leaving lots of room in there for that sort of thing. Now, one other thing I wanted to mention real briefly, and then I'll leave this and this next one. I need a good example of, I need a wave file. I think there are a few things on the list that we didn't kind of get into. I'm going to leave the sound, 3D sound off for now. The idea was that with 3D sound, you can position sounds in the environment and then have sound move according to the movement of that object or the movement of the listener with regards to that object, right? So you can get dynamic sound kind of automatically based on the player movement. So if I position an audio source, let's say I put an audio source somewhere in my scene, right? If I put it, over here versus another, and this is we'll call this one scary left. And I'm going to add another one audio source happy right. And we'll have to put in a good example of these. So I'm going to put happy right over here and scary left over here. And you'll notice in here for the audio sources, there is this 3D sound settings. Right? So if spatial blend is set to 3D, now the audio level of those will be affected by wherever the listener is. So you'll see that the main camera has the audio listener on it. So in this case, we're going to switch the, I guess in a lot of cases, normally the main camera would be the right thing to have, but let's move the audio listener to, let's put an audio listener on our capsule. And remove it from here. So if we were to look at, I'm going to lock this for just a second, and I'm going to move the capsule around. Oh, let's see, make it linear. No. I'm going to come back to that. That's what I said in the first place. I should have stuck with my guns on that one. So the idea, I'll leave this as a research project to be sort of inspire you in the meantime for on Thursday if you're as we don't have class. The idea is pretty interesting in that as you move towards, as the listener moves towards or away from an audio source that has 3D sound settings enabled, this level you see this should be moving up and down according to my position there, and that one I will leave for you to find out. And there are bonus points for that one. That's I'll make that a 3-pointer since I didn't finish the example here in class. I'm not quite sure what I've left. What is it? Bypass listener. Normally I'm really good with 3D sound. We'll leave that as the introduction. The one other thing to mention, though, the other feature to make you aware of, to start thinking about, and some of this may be, I want to rush through some of these just so as you're thinking about the design for your game, implement it afterwards, get design and decide sort of like what features you're going for before having them go all the way through. is the really cool, never boring, never gets old particle system. We haven't talked about particle systems, have we? Okay. So particle systems are sort of little miniature physics systems in and of themselves. They're a great way to do, you see them used a lot in things like smoke and fire, things that have sort of a direction. You can use them for volumetric effects where there's just kind of little particles floating in the air, or floating in the atmosphere. You can do things like rain or all sorts of things where they have an overall system to them, but there's also a certain unifying behaviors that everything has. Every drop of rain, they fall out of the sky. They look kind of the same. They're about this size and so on. They have a life. They're particles within the system, and there's some way to sort of describe overall how it goes. So most game engines have a particle system of some sort that you can use, and Unity, of course, is no stranger in that. So it has some built-in type of systems, particle systems you can just add, like from this menu you can say, okay, go to an effect and add a particle system. And there's some other effects as well. These would be worth points, trails and lines. I'm going to leave that as a discover on your own, trails and lines. And particle systems, yet another one. So let's unlock this so we can see the particle system. And you'll see now, the moment it starts working, it's even in the scene, the moment it's selected in the scene view here, it starts to kind of show what the particle system would be doing. Right? It is now emitting particles. That's what particle systems do. They emit particles according to a set of parameters. Right? At the moment, the particle system here, let's open this. We want to look for, oh, it is using the sprite-lit renderer. Now, I guess the thing about it is that I don't think they're being lit. Let's see, in the game view. All right, we're not seeing them there. And let's make sure our particle system is also in the front here so we can we entirely lost it here. Restart. All right. So normally in here we would have the particle system shader. Let's see. That's sprite lit material. We don't want that. We want to select shader and this is a good question because normally we'd be using a default particle shader. And I don't know, maybe we've run into an area here. Let's see, particles. Ah, there we go. Particles lit. So let's go with that. Uh-oh. Oh, I don't want to edit it. Sorry. So this is one of these odd cases where we did not have the right shader here. So with particles lit, let's tell it that we're going to, let's see. Particles lit. We don't have a think I may have to get interesting here. So we can create, go to our assets here, we're going to create a rendering, no, we're going to create a, find our shaders here, our material, and we want this to be based on a simple lit particle shader. This is our new material. All right, that worked. Except it's a square shape. Well, let's see. The combination of Universal Render Pipeline 2D shading and particle systems. Let's do this. Let's see. Let's choose. I'm going to choose a shape here. Okay, I got it. All right, default particle. And alpha clipping. All right, surface type, transparent, even better. All right, that was scary, but no, it's interesting. It's not in the game yet. It's in the scene. So we may have to tell it to start. Particle system looping, yes. Duration, yes. Let's actually there we go, towards the front. I think we really want to use sprite-lit default for that. Okay, we're going to have to work with our material a little bit more. Create material, and we'll call this 2D particle. Particle. 2D particle, which is now based on a 2D sprite-lit default. And our texture is our default particle there. So, particle system. Now they're lit, or not lit, so I need to go in the game and Crank up the global lighting. Why? That's the material. Oh. Don't have an answer on this one. Let's go back to get rid of our maximize on play. I'm going to turn off some of our backgrounds here just to see if I... Oh, yes. Are they? Am I just not in the... Oh, gosh, you're right. Oh. It's not my day. Oh. Yeah. All right. How many other things could I change before that obvious? All right. Well, along the way, we saw some of the ways that you can tweak materials. You can create your own materials, and you can modify the attributes of those materials, like which shaders to use. In this case, I unnecessarily changed a built-in, created my own on-the-fly particle shader where I assigned a specific texture to be used on each of the particles. So if I wanted to create something where the particles weren't these fun little dots that jump out of there, I could have gone in and like modified things about this now, so I could even tweak them via their material. Look at that. Anyway. Okay. So, important thing, make sure you can see the thing you think you're editing. Not my day. So, let's go back to looking at some of the parameters of the particle system then. So right now it's just using the defaults. So you'll notice that there are tons and tons of parameters for particle systems. And that's because they are really their own little physics engine and they have lots of ways you can kind of set them up for depending on what you're trying to sort of simulate. So right now we just have sparks sort of flying out from a common source. So the nice thing is that you can kind of edit them right in here, and it will show, you can simulate them as long as they're selected in your scene window. And we can say, well, it doesn't loop. So if you had something that just a shower of sparks and then dies off, you could say, well, it doesn't loop. So when it comes into existence, it plays, and then it dies off. So we'll say it's going to loop, and we can do things like say, well, they start off with a certain size, right? They start as their normal size, just 1, and their color when they start out, we might try to tint their color. Right. Create sort of a smokier kind of thing. Make them a little bit more transparent. Whether or not it plays on awake, just any kind of dynamic system like this or an animation, whether or not it plays and plays through. The maximum number of particles. So we can increase the number of particles because particles tend to have a lifespan, right? They're born, they live, they die, right? So this is the number of particles at most, right? So if you were programming inside of OpenGL or inside of Vulkan or something, this would be sort of the pool of, or the instanced, the number of instances of the core particle that you would use. Right? So this is some of the basic things here. So how long from when it starts does it play? How long does each of these particles live? So if we restart, notice now they all tend to die off real quick. So within 0.2 seconds they die. Right. 5 seconds they spawn off and go. So the control you have over them, you have control over things like emission, which is the rate over time. So this means you're going to get 10 per second. Right? We increase that, we get a much denser particle cloud. Now we're getting, say, too much. Oh, there's a burst. Oh, why is it doing this? Why is it sending smoke signals all of a sudden? It's because it can only have 500 maximum particles, and it tries to do them at 500 per second, and they have a life of 5 seconds. So we burst out 500 particles in 1 second, and then we can't have any more particles until 5 seconds passes, which is so every 5 seconds we have this 1 second burst of smoke. So what we should obviously do is move that to the top of this volcano. Something like that. And it should be behind this tree. That would be kind of cool. But anyway, that's too specific. All right, so I'm going to decrease the rate over time so that we'll wind up with a more continuous. Now we have 100 over the course of time. So in 5 seconds, which is their lifespan, we're going to get a nice even flow, right? There's 100 per second, and they have a 5 second lifespan, so it's going to look fairly continuous, right? You'll see eventually up here they've all died out. So if this is our scene, maybe we don't need them to live for 5 seconds. Maybe we can have them to optimize things. We could say that their lifetime is only 3 seconds, because that gets them out of the scene, right? Good enough. All right. Now we have our rate over time, rate over distance. So this will be do things like say, well, are they denser early on And this is going to matter more when you have a different shape emitter. So we'll look at emitter shapes. Right now we're emitting in a cone shape. We can emit in a sphere. So just emitting all over the place. We could do a donut, which you can't tell too much without kind of messing around with the inner and outer radiuses. All right, so now we've got this kind of weird torus effect. You can have them from meshes. We don't have a mesh assigned, so if you had some kind of surface that you wanted to have fog or atmosphere growing out of, like the valley that you model, and you want to have haze down at the bottom of the valley, you could have something like that. Or clouds that rained. Boxes, circles on. Let's do, we just do plain circle. Now this is interesting because it's a 2D circle, and by default, if we look at the top here, it's already rotated our renderer or our transform here. So if you were in 2D, you probably want to set this to 0, 0, and if you're going to rotate it around Z. Right? That's just something it does by default. So now in 2D, we don't want them to be, they were emitting in 3D all around in our sphere there. So in a 2D game, it makes sense to go either a circle or some of the shape based on that. Hemispheres are kind of cool too. Let's see, circles, we can also mess with the arc of the circle. So say we wanted to say it's just 45 degrees. So this is probably the more efficient way to, we want to rotate this around. Right. And decide, do things like at what angle do they go in straight lines, basically. They ping pong between the different arc points here within the arc. But random, depending on their spread, 0. All right, so at 0.25, it's going to divide that into, or 0.25 is going to divide our arc into 4 parts and randomly send them in along those different parts. You set to 0, then it's continuous then again. Okay, say align to a certain direction. We don't do that. All right. Then things like we can even say, well, they start off fast and they move slower. So you can do things like over the course of their lifetime, they're going to speed up, or no, here they're slowing down, right? They start off fast, and eventually out there they start to slow down a bit. I think so they're really kind of firing out real fast, too fast for their own good. You can create limits to their velocity over time, so they can speed up to a certain speed and then stay at that speed. Inherent velocity, I've never used that one. I usually stick with kind of the basics. Whether or not you want them to collide with other things in the scene. You can actually turn on colliders for all the individual particles. So if you wanted to have, hail that actually bounces off of the ground, you can do that. You can say have them change color over a lifetime. This is kind of a fun one. So we start off at, let's see, this color down here, we'll make it like that. So between 0 and 1, they will go from black to white. That may be conflicting with the sprite and the starting color. I had to turn that one back off again. The case of almost too many parameters to change here. All right, there we go. Interesting mix here. Another fun one is trails. And this is another one of those that we have to be careful because you have to set a renderer for the trails as well, which, notice, assign a trail material in the renderer module. So we have to come down here and make sure that, let's see, this was for the trail material. We have to select now, choose our 2D particle. Now you can see that they leave these sort of streaks as they go up. I could play with particles like just all day long. There's like so many things you need to tweak over them. But some of the most important ones, depending on what the use is, do you want it to be exhaust? Do you want it to be, an explosion? The simplest things are, like explosions have a, 360-degree wow, something got really, oh, that's radius, not arc. All right, scroll back to there. You're making an explosion, kind of a cool black hole effect. Kind of the opposite black hole if you animated it backwards somehow. Or if you're trying to do something that is more directed, a certain beam or an eruption or an exhaust or that sort of thing. So a little goes a long way, but they're lots and lots of fun to add personality, especially to things like explosions and exhausts. I had one game where like just the little character is running along and kind of located a particle system like down at his feet to just kick up a little dust every so often. So every time he would walk, he would momentarily turn on the particle system and just kick out a few little, dust particles. Kind of a fun thing to do. So it's a great one to use your imagination with. And we've gone over our normal time. I mean, not over class time, but over our normal allotment of time. But giving you some really fertile ground, you might have been thinking, well, we've exhausted our possible feature points. We've already done everything. How are you possibly going to get to 100? Creative use of this. So I would say, using a particle system, each particle system that you use in a custom way. So if you used a particle system for a volcano and you used a particle system for the dust off the player's shoes and you used one for the explosions of those would count. Probably get some feature points for each one of those sort of things. Same goes for how you wind up using post-processing and how you use lighting and so on, right? Because you can certainly go very deep into these things. So if you just put one in with default values, that's one thing. That might get you a point or two. If you really go into it and use them in very rich ways, then they get up to so between basically 1 and 3 feature points per use of them, depending on how you're really using it, the effect there. If you're doing post-processing like this, post-processing volume, I'm not going to give you like 1 point for each filter you add, because then it's like, okay, I added every possible post-processing effect. Want to see them used in ways that kind of make sense. That experiment with them, try some different things out. Certainly have a lot of creative license in there, but do check them out. And I'll put something together or point to some resources if I can't figure out exactly what silly thing I did today. Obviously, the particle system not on the screen was a real silly one, but in retrospect, the 3D audio one is probably just as silly. I'm sure I'm just forgetting some parameters somewhere. Lots of food for thought. Anyone have any questions on any of those, or just go ahead, try them out, figure them out, design. So think about how. Don't just suddenly say, "Yeah, I can put volcanoes everywhere." Make it sit in. That's why I want to have a design and overall feeling to what the game is going to be and why you're kind of laying out things or how you're going to do them. Yes.
Is there an easy way to apply the shadow caster to like a tile map?
If the problem is it normally wants to do just like a square, so when you put it in, it's just going to say the whole extent of it. I don't know offhand. I know that it is kind of that brute force of it is I thought. There's the composite shadow caster, but I think that's just combining. That's why I tried to put 2 shadow casters on the same object so you can combine them, but I'm not sure. I think it must just combine them for shadow casters within a single hierarchy. Yeah, I don't have a good answer for that one. I'll have to look that up, but it's a good question. In one of the games I did, I just kind of drew it out by hand. It's nice that you can kind of create an arbitrary polygon in it, but it has to be kind of one continuous convex or concave, but it has to be one hull. You can't have like an island here and an island there. So you have to create bunches of them. Okay. Any other questions? All right. Well then, think about all these new capabilities and how they would sit in your game in a way that really makes sense. And let me know if you have any questions. Shoot me a DM on Discord. Happy to help at any time. And we won't be meeting in person on Thursday. We'll just say that for sure. But we will meet next week, right, unless otherwise noted. So always pay attention to what's going on in Discord. Try to email blast and Discord if anything changes.